All right, thank you all very much for coming. My name is Craig. I'm the global lead for compute in our go-to-market team, so I look after supporting the field teams with Google Cloud Platform worldwide. So wandering around the hall before, I thought I might be a bit of an odd person to give a talk to this audience because I was just trying to calculate it's probably almost 10 years. Right, that's going to be cool. Just one moment. The theme of security will come up later. So we'll make sense. Sorry about that. Right, so trying to figure out the numbers. Probably the last time that I was responsible for machinery that was in a data center, specifically that I could go in and touch and point to, was in about 2007. And gear that I could conceivably go visit and touch was about 2010. So along with a lot of people, I've been moving further and further up the stack in terms of virtualization. It's been a long time since we're all dealing in client networks, we're dealing with wireless networks, so we're not touching network cables anymore. Moving further and further away, but still moving further up the value chain. So the title I was going to talk to was Back to the Future, which is a bit moderately topical, but I'm sort of looking at it through the lens of what have we done in the past, and what might we need to do to reinvent what we want to do in the future if we want to remain relevant, especially as people who may be responsible for data centers or providing connectivity, providing resources to developers in the business. So to ask the question is, well, who are these customers? Where are they? Who are the people we're supporting? Traditionally, we were something like this. We were people at desks that we paid for. We paid the salary, we paid the desk, we paid for a computer, and you controlled all of these things. You had responsibility for setting up a big perimeter around them. You built yourself a big wall. So for someone to get access to all this technology from on the weekend, for example, they would have to come in, use a key or a swipe card, and come to the inside of this wall. And then the model evolved. We started saying, all right, well, there's dial-up and there's VPN, so now we're starting to let people get access through this, and moving to a world where everyone can access all of your internal systems from the internet. It's a bit scary for people. But you think about the perimeter model doesn't make sense anymore, because you previously have to break in to get access to everything. Now all you need to do is find someone on the outside who has that access and just trick them into doing it for you. That leads to today's customers. Where are the people we're supporting, working with today? So increasingly, we're dealing with staff which we'll call the millennial, the Gen Y generation. So I'm slightly outside that generation. But 66% of millennials expect to work flexible hours, either in the home or in the office. 56% of people in a different study said that they wouldn't choose an employer that wouldn't let them use social media at work. So we're starting to deal with a very different set of people we need to support. So you might not control where these people are, or ultimately you might not control what kind of device they're using. And in 2007, it was the first time where it was turned around and the CEO walks in with the iPhone and says, you must make this work on my network, rather than the IT team dictating what technology they would use to support this. And so more and more applications now are simply services delivered over the internet or over the HTTP protocol to a device. And that's fantastic because by and large, people have better devices and are willing to refresh them more quickly than you can be bothered providing them as a company. So you can have the BYO device model, and you can move to actually just providing a service that runs and will run on any of these devices. So today, 50% of all adults worldwide own a smartphone. And estimates now say that by 2020, there will be 8 billion connected smartphones, which is twice the number that we have today. And these are connected via, effectively, in Western world at least, they're connected via a low-cost, high-bandwidth connection back to effective infinite compute resource, which either you provide or customers will find a way to get access to themselves. They'll just start using other applications. So this is what a PC looks like today. This is Google's new Pixel C. But if you think about the iPad Pro or the Surface Book, they're both exactly the same. They are a mobile device which is designed to replace all of the things you would previously have done on the PC. But they have new sensors, they have cameras, they have gyroscopes, they now have keyboards, but they also run on battery. And users are incredibly fickle about applications. If they find that there's something that's using up all the battery life on their device, they won't use that. They won't do whatever the function is that's provided by this. So we have to start thinking about how we provide power-efficient experiences to people, which is something that we didn't previously have to do when we controlled the desk that they plugged into. So what you think of as a mobile and PC divide, it doesn't make sense to say, here's something that goes in my pocket, here's something that's on my desk. Ultimately, we're going to have here are battery-powered things, and here are plugged-in things. And some of the times, these devices might be plugged in, but increasingly they're going to be used anywhere, and that could mean anywhere around the world. So thinking about it from an enterprise IT perspective, we might say, well, what goal do we have? What are we trying to achieve? And one of our recent cloud events, we put this slide up and said that the goal is to make better software and make it faster. I'd say that the standard for what better software is definitely keeps rising worldwide. It's a noble goal, but I don't think it's what we should aim to do. Because that's looking at it rather than stating what the problem is. It's supposing a solution. What we really want to do is we want to solve business problems. We want to find ways to solve, using IT, if it is the right thing, the problems that employees have. And it's been demonstrated with the rise of shadow IT over the last few years, that if you don't solve these problems, your employees will get their credit card out. If they're lucky, they'll use their corporate card. They might just use their own, and they will buy access to whatever service they think best solves the problem for them. So if we're providing data center resources, well, what is it that we provide? How are we going to be relevant to these kind of people? So for a long time, the idea has been OpenStack. Now I want to suggest that this is possibly a little bit lower than where you need to be pitching the resources you're providing to people. In the 1960s, the airline industry discovered computers along with the rest of the world, and they implemented travel control systems for checking you into airplanes on large mainframes, and they put dumb terminals on the desks at the airport and at the travel agents. In the next 20 years, we developed newer and better input methods and ways of interacting that look like the PC. And while that's nothing compared to what we think about today, the PC had high-resolution graphics, it could make sound, and you could plug peripherals into it that would let you have a different experience. But what the airline industry did was they ran a terminal emulator on it, because that's what they were used to, that's what their people were used to. They thought that there's no way that we're going to be able to get any benefit from this, we just want to do what we used to do. And that's when you get into the situation that they describe as disruption. Is if you build something that's a previous experience, something will come along that's not very good, and you'll laugh at it and say it's not very good, but it will continue to get better along the time scale that you start increasingly becoming irrelevant, and by the time you think about it, all of a sudden travel purchasing is done on the internet, for example. So in terms of applications, here are a few of the things you might need to provide if you want to provide an application or an environment for your developers to write applications. They'll have to do the development, and then you'll have to worry about provisioning resources, and if it's successful, how am I going to grow them, how is it going to be reliable, how do I improve my utilization, how do I drive down my costs, how do I monitor the system and make sure everything works as it should. And ultimately, all the programmers want to do is this thing, they want to do the development. Someone else can provide the piece in between that will let you scale your application, write something that works out of the box. You don't want to focus on infrastructure, you want to focus on business value or insight. So I'd argue we need to transform how we build software. And now we talk about where we build it, where we operate it. I don't think any of you should be able to disagree that the cloud is here. It exists today, There are a small number, a decreasing number of hyperscale vendors. I would argue that there are 4 major, what I would call hyperscale compute vendors worldwide today. One of them is Facebook. They're downstairs telling you how they build and give away their server designs. That's fantastic, but you can't pay them to run compute in their data centers. The other 3 vendors you'll be familiar with, the big players, Microsoft, Amazon, and Google. You can. So this is our recently retired CTO, Patrick Pichette, and we don't talk about the details of what we build, where we put it, in a lot of detail. But one thing that I could find an actual quote is on an earnings call a few years ago, Patrick said that Google is probably one of the largest server manufacturers in the world. Analysts have said that at the time it was probably in the top 5. And we don't sell servers to anybody. We're not Dell or HP or IBM, we're not selling these servers. We're building them to our specifications to be able to run workloads at this kind of scale. And the economies of scale and the privileges you get when you're buying this kind of scale of equipment mean that it will be harder for smaller vendors to compete in this space. It's becoming a commodity market. This is a picture of one of our new data centers. For scale, you can see one of the old ones behind it. This is a new facility that we're building in Singapore. Again, the scale that's being built at, there are a small number of people who are doing this kind of scale. But that doesn't necessarily mean that if you aren't running at this scale, there's nothing you can do. We run the largest non-telco network in the world, but we make that available for people to peer with and connect with in terms of the service we offer. The economics of the cloud don't just apply to our cloud platform, but they apply to all hyperscale vendors. You provide, effectively we've said Moore's law has reset the model. If you assume that every 2 years you should be able to get twice the server capacity, every 18 months you should be able to get twice whatever it is for your budget. Another way of looking at it is that year on year your prices will drop, and it's not quite 50%, but it's about 40% year on year. And a number of vendors have said, all right, well, we'll give you a couple of pennies off every now and then. But we've come in and said, well, look, the cost of delivering compute has come down, and started in effect a price race between many of the major vendors to say, this is what we think it should cost to deliver raw commodity compute. It's becoming like electricity. It's becoming something where you think, there's no point in just providing commodity compute when I can buy it from a different vendor. And so the question then is, how do you compete? And a way to look at this is that in the electricity space, yes, we have national grids and we have providers of a large scale of infrastructure, but people like Google are crying out for what I would call boutique energy. We want carbon neutral, we want wind farms, we want people who are able to provide a service that's different to the master. And in data centers, the argument is, well, look at Rackspace. They've basically decided they're not going to try and compete in that commodity market. They're going to offer support, and they're going to offer it on top of the main vendors. They're going to do the white glove managed services that people like Amazon and Microsoft aren't prepared to offer. As we'll talk about in a second, you cannot scale the number of people that it requires to run a service and expect to be able to keep dropping prices 40% year on year. So you might be able to provide service in a location that a hyperscale provider can't provide or won't provide. But you need to look at a way of being able to interoperate so that the hyperscale provider can give you the commodity at the price that you can provide to your users, your developers, to keep them relevant. Developers today demand open. So one of the other things I was asked to mention was open source. We find that people are coming in to us today with experience with all of the open source technologies. If you bring these people in and ask them to work on something that's custom that they haven't had a chance to be familiar with because it's expensive or it's proprietary, it takes them a lot longer to get up to speed. The skills that they develop are transferable, but the technology they develop, they can just pick up. And a lot of these vendors are building things on the side. It was not the primary business of the bookshop to sell servers. It's something that they could have came into. There are a lot of businesses who are finding things that are not their core competency. They would rather share with everybody, let the community take on some of the responsibility, grow it together so that they can have the benefit of someone else doing the work. But then they can also get people who come out of school with some experience in these technologies. Open source rises the tide for all the boats. And if there's anything that makes you think this isn't something that's happened now, this is Microsoft's GitHub page for the .NET runtime. They've taken something that was core to their commercial environment, core to selling server licenses to run Windows, and now they're in the process of making it open source because they want to remain relevant. They are the people who 10 years ago were writing the memo saying that open source was a cancer, and they have admirably turned the ship around on this. This, if nothing else, I think suggests that if everything isn't open source today, it will be soon in these commodity markets. So we released a paper 10 years ago talking about a system we run internally called MapReduce, a model for doing large-scale parallel computing, which is the kind of thing that you would want to do if you were downloading a copy of the internet and then wanted to build an index of it so that you could serve search results. And what we would do is participate in computer science research communities. We would release these papers, we'd say, here's how we did it, here's an implementation, it's fantastic. And then other people would say, that's a fantastic idea, I'm going to build one of those, and I'm going to release that open source. And Hadoop is an implementation of the MapReduce and the GFS systems that we use internally. And this is a fantastic quote from Doug Cutting, who was the creator of Hadoop, talking about one of our newer papers a few years ago. He says, Google is living a few years in the future and sending the rest of us messages. And that's fantastic because you can take those things. You can say, these white papers are going to become something I can implement. The open source that comes out of that is something that I don't have to build, yet I can provide to my developers and to my customers. It was important for us to be able to do these things on the cheap. When you think about the launch of Gmail in 2004, for example, we were providing 100 times the amount of storage that any other provider was giving for free email. And the only monetization on this was a small text ad that was displayed along the side of it. To be able to run at that kind of scale, you need to run very close to the bone, at very low cost, very low overheads. So one of the things that we sit behind as a very important tenet of how we're able to do that is the idea that you should not treat a data center as a collection of computers. A medium-sized Google data center may have order of tens of thousands of computers in it. But you need to be able to treat them as if they are a single computer. And what that means is that the number of people that it requires to maintain a system like this shouldn't scale with the number of machines that go in there. You shouldn't need to have more people. You should be able to just have the software handle this. So the message from the future is that we wrote about this. First of all, we published a book. This is Urs Hosler is basically our CTO, effectively our Senior Vice President of the Technical Infrastructure and runs the cloud division now. And we said, here is what it takes to be able to develop and run warehouse scale machines. This is the second edition of the book. It was the first edition of this book that inspired the Open Compute project at Facebook and some of the work that they did. We continued publishing academic white papers about how to perform the optimization and run these clusters internally. So we published, in reverse order actually, a paper about the system we use to run internally, and then a paper about the scheduler that we use, the second generation scheduler, in order to be able to make decisions about how to run jobs. And there's an awful lot of detail on these papers. I'm not going to go too much into it, but to say, for example, we found that if we had two different clusters, one of them would run production workloads for real-time serving, and the other would run batch workloads for updating our indexes, for example. There would be 25% overhead that's wasted capacity versus taking that work and simply running it in the spare time that we have available on the production cluster when it's not doing anything. So you pack all those things and treat them as if they're the same machinery, you get 25% efficiency gain. And when we're thinking of something that's multiple billions of dollars to build and run, that's serious money. So we published between these things, so we published the Omega paper, and then implementations. There were people who left Google and went to other companies. They went and worked at Twitter, and there were students who floated in and out of universities and started things. So Mesosphere is a company that was founded based on the idea of the Omega scheduler. There was an implementation done at Twitter called Aurora. There are people who had worked internally, taken these ideas, and from that sort of 1,000 flowers bloomed in terms of how you can do that efficient compute yourself on your own hardware in your own data center. But between publishing our V2 paper and then our V1 paper, which I said came afterwards, we sort of realized, well, we'd thought of that V1 system as the secret source. We thought that's the thing that lets us do these amazing things, but we saw that there were other people starting to implement these ideas. And they were making mistakes. They were making mistakes that we had found, and we'd said, right, we've got a year's worth of experience that says that's not a good idea. It seemed a really good idea, but it turned out not to be. And then we want to make sure that people are only ever making new mistakes, both in the research community and out there. We want to make sure people aren't actually doing the same thing wrong twice. So our cluster server, we introduced some of the concepts of Linux application containers. And this is a very sort of popular topic over the last couple of years. We released the support for C groups in the Linux kernel a few years ago. Other vendors from running their own platform as a service eventually spun out the technology from that as a company called Docker. Docker is very popular today because it's a very fantastic way of providing tooling around the idea of packaging up an application with all of its dependencies and saying, all you need to provide me is a computer that runs Linux, and I'll do all the rest myself. I don't need to worry about any of the things, the dependencies, and making sure libraries are up to date, rolling forward and rolling back. All of these things become very easy. So we published that we launch over 2 billion containers per week. This is something we know a lot about, and we wanted to get that information out there. And instead of just writing a paper about it, what we did in this case was actually release some open source software. We released this program called Kubernetes, which is Greek for helmsman. So you think about the leader of a container ship, for example. So what we did not want to do is just take what we had built 10 years ago internally and wrote these papers about how it worked and throw it out there and say, you can have this. Because it doesn't make sense anymore. There were a lot of assumptions that we made at the time, a lot of sort of dark alleys we went down that eventually went into production, where we said, well, look, we wouldn't do that if we were going to do it again today. 10 years ago, there was no concept that there might eventually be IPv6 in production. There may still be no concept of that today, depending on your opinion on that. But we can think of a world where the things that used to be scarce may not be scarce anymore. So we're able to do things like allocate every unit of work its own IP address, thinking that eventually we're going to be in a world where everything is addressable, or if not today, you just run your own overlay network on IPv4. So what Kubernetes is a distributed systems toolkit. So it's not just an orchestrator or a manager. What we really wanted to do is make building a reliable, agile, scalable, distributed system as easy as writing hello world in your first computer science class. It handles a bunch of the concepts that you need to run. So first of all, it acts on these Docker containers and it's primitive. Like we said before, people are coming in with experience. We're not going to succeed if we're bringing something out which requires something completely different to what everybody's using. We're meeting people where they are. We're saying, you're familiar with this, this is what we'll support. It handles obvious things like replication, scaling up jobs to make sure that you're able to run thousands of copies across thousands of machines if necessary in order to be able to serve large numbers of users. But it also has some interesting concepts about how you need to group various services together in order to be able to support things like logging and monitoring, which are very important. If your service isn't being monitored, it shouldn't be running. We introduced discovery systems in order to be able to make it easy to say, well, previously I knew I just called out to the server named Bob, but now I have 1,000 machines, I don't know which one I need to connect to and what that actually means. And so rather than having to rewrite your application, we want just to be able to call the service and then have it retrofit the service discovery for you, so you don't need to have your application know that it's running in this, which means you can have a test environment which is a lot smaller or maybe runs on your own laptop, but runs the same code as runs at scale in production. So Kubernetes is extensible in many directions. So it's written in Go, which is a very popular open source systems language. Go in itself was trying to solve some of the problems of what would C look like if we were writing it today and we had the different constraints that we didn't have in the 60s. So it's extensible in the sense that it can run on tin in a data center. It can run on top of Mesos or other scheduling services. It can run on top of the cloud. And in that sense, it really becomes portable, because what we want is this API, which we're putting out there, to say, here's how you can run distributed systems. You can run this as something you provide from your internal data center, from a data center provider. We provide a cloud-hosted version of it. Other cloud providers will be able to do the same thing. And then you will truly be able to pick the location where you run your code based on its merits. or as we'll talk about in a moment, run certain parts of it where there is a legal or compliance reason to do so. It's a very lean system, and that, again, we knew the things that would run in this environment need to run. We don't want to put a lot of resource into running the system. We want the resources to be able to run your code. So the revolution that's being powered by containers today, developers get easy dev test environments. The code that runs on their laptop is the same as the code that runs in production because they're packaging all the pieces up together and they're just shipping it around. As simple as copying a file. If your deployment doesn't work, you just roll back to your previous version. You don't need to worry about did it complete. It's very atomic. So if some things in a previous deployment had to go right and then your last piece failed, you'd have to roll those things back and then it could go wrong as well. It makes it easy to run those rolling updates. So for various different deployment patterns, you might say, all right, well, I'm going to run a small percentage of my new code, check that the traffic to it is successful, and then move the major percentage over, and then check that's successful, and then eventually run 100%. There's a whole bunch of different continuous integration and delivery things that you need a system like this in order to be able to provide. But it's not sufficient by itself. You need to drive these sort of organizational changes. And microservices, again, another common buzzword for today. This is a great system for sort of composing microservice architectures. Developers should just write their code, and a system should decide all the rest of the things about how it runs. We program a flight controller. You set an autopilot. You say, this is what I want. And then the system will say, okay, well, things have happened. This server crashed. This one's offline. It turns out that you don't have what you asked for because of that. We will run this loop and we will continue to correct the environment and then bring it back. And you update those environments based on instructions like I want to scale because I'm under demand, which might come from one of your load balancers. eBay, for example, they run an internal system which is similar in size to, say, Rackspace or SoftLayer in terms of the number of machines that they run. And they are now retooling with Kubernetes on top of OpenStack as a way of giving this higher level of abstraction to their customers. So we want to give the world where developers just write code. A good distinction to make here is that Kubernetes is not in and of itself a platform as a service or a PaaS. It is a platform upon which you can build that platform. And an area, a customer who's done that, or a vendor who's done that, Red Hat, who built a thing called OpenShift v3, which is their platform as a service offering. Everything you see in the box on the right, the gray background things, that's effectively provided by Kubernetes. So the storage layers, the interaction with clouds, physical virtual machines, the software that runs on the nodes, and all of the distribution of state is all handled by that. But the parts they've added on the top are integration with source code management, integration with build systems, CI/CD and tooling, integration with enterprise systems. They've done a lot of work in the open source part on the right. So they've worked very closely with us, as have a lot of other vendors like CoreOS, VMware, Microsoft, IBM, contributing to the open source part on the right to make this work well, while adding their own value in terms of the piece on the left. If you think about Twitter a few years ago, they started off, they wrote their application, and then they got to the point where they collapsed under their own weight because it was something that they wrote very quickly in Rails to get a product out there, and then it wasn't able to handle scale. So they would have the whale for a while, and then they spent up to a year rewriting their code, and since then it's been all built on Java and microservices. But that took a lot longer, and if the company had built that from day one, then they wouldn't have been able to get that kind of speed to market. You compare that with Snapchat, for example. They run on Google's platform as a service, which is called App Engine, which is powered by our container infrastructure. They run the same code that they ran to support 5, 10, 15 users to support almost 1 billion users today. And they haven't had to change anything because they have a system which is able to handle that scaling. But the platform piece at the side makes it easy enough that you can start and quickly validate an idea. OpenShift is an example of a service that you can provide to people, targeted more obviously for enterprise use cases, but that lets people very quickly test an idea out, low cost to both success and to failure. And the quicker you can fail, the quicker you can move on to a new idea. So we think that any modern software stack needs to have these 4 properties. It needs to be self-healing and self-managing. It needs to support microservices. It needs to be very efficient. It needs to be very easy to monitor and debug. And while microservices end up in situations like this sometimes, where you have so many different things you need to check when you're talking about, I used to have one application and I knew how it went, and now I have to look at all the interactions between things. It's exponential. The thing about microservices is that they let you break your code down to a point where developers aren't scared of changing it anymore. If you have a legacy application and you think, well, changing this one thing might change everything else here, I'm not going to do that, or it's going to take a lot of investigation before I can make any kind of change. The alternative is we have these little services, and they should actually map to business problems. So you can lower business risk by using microservices. Because you can have a small team, what they call the 2 pizza rule in Amazon, for example, is the group who work on this service should be able to be fed with 2 pizzas. And then that maps that particular service not to a technical domain, but to a business domain, and lets you solve a particular problem in a group, and then lets you define boundaries between the finance team and the storage team and the procurement, for example. So you lower that fear of change, and so you lower that risk. And that lets you build something that's scalable, because depending on which of those services needs to be scaled, it's very easy to do so. So that's some idea about how we think applications should be written. I think it's important to note that we don't think that they're going to all run in one place. The next version of Kubernetes is due out in about 3 months' time. 1.2 will support federated clusters. And what that means is we don't necessarily want to deploy code and say, well, some of it can run in the US and some of it can run in Europe. There could be reasons why you want to run in one of those locations only. And you can have a bad experience if you're doing replication, that you're not treating these as if they are distinct, separate environments. What we want is a world where you can distribute with rules your software and say, this particular part must be PCI compliant, or it must be running on a particular machine which runs in my data center environment, has an HSM, has some particular requirement to be in a single country's jurisdiction. But all the rest of it, I don't really care where that runs. And you could imagine a world where it can run with whoever's cheapest today if it's running a batch job, or in whichever zone has the most capacity. And vendors might start saying, we'll give you cheaper capacity in the particular location if you choose to run here versus somewhere else that's busy for whatever reason. One final point on the perimeter model. Again, with these devices running worldwide, it's not really, we've realized that doesn't work anymore. We published a paper, again, a year or so ago, a thing called Beyond Corp, which is worth searching for if you're interested in looking at how this might work for you. The idea is now is that the Google internal network isn't even behind the perimeter. The idea, a Google network is simply the same as the internet, as far as we're concerned. So when I walk into an office, I don't have any more privileges than I do if I'm using a machine on a public Wi-Fi here or at home. And you need to move the control then down into the device, the certificates, in order to be able to make sure that you have trusted devices. But all the functionality exists that you can do that on your phones, and you can do that on your tablets as well as your PCs. One last thing, it's not enough as a cloud provider for us just to take the things that we provide to our staff internally and make them available externally. We run a Bigtable service, which is the NoSQL database that powers our everything within Google and has for many years. But we've now made that available as a cloud service, and how we've done that is we've actually taken the open source implementation from the Bigtable paper, was a thing called Apache HBase, and so that's an API that people are used to using. We make our original version of Bigtable available with that HBase API because we realized that if we just put something out there and it's not what people are used to using, then they might not choose to use it. We need to make it as easy. We need to go where users are. Similarly, Netflix are famous for a set of deployment tools for Amazon's cloud. They've just released their second generation, so they moved from a system called Asgard to a new system called Spinnaker, which is a continuous delivery system for turning on instances, doing testing in the cloud, and then can eventually manage your production environment. And we've been talking with them a while about how we can cooperate, and it turned out that they were interested in building this new system. So from day one, we worked with them to have it support Google Cloud Platform out of the box. So as people start using these higher level abstractions, things like Terraform and other open source tools, if you're running one of these environments, think about how you can provide something which these tools will support either by adopting a common API or working with the vendors to be able to have it, as people come out of school, they're able to develop something that works efficiently for your developers in your environment. Thank you very much. So I think we have a few minutes for questions if anyone has one. Just throw your hand up and there's a microphone which will come to you.
Are you seeing any traction from telcos have an interest in this type of platform as they look to migrate their proprietary systems to NFV platforms or even work in the over-the-top service provider market?
Telcos, I feel that there's two different aspects to it. So there's definitely a lot of interconnection. So there are a lot of places where, the graph before, all the locations we have worldwide, they are starting to offer peering in these places so that they're able to do, like I say, to run hybrid environments for customers when they run their own data centers. There are still some regulations which we see for the high-level cloud providers. I don't believe that you're able to run a real-time audio service on top of Google Cloud Platform, and I think that's tied up in 911. Again, if you choose to run in this environment, then there are regulations that are different. So that is one differentiator where you might want to say these services that do the telco switching need to run on TIN in this environment. But all of my systems, ISP stopped running email a long time ago. This is something they said, well, there's no differentiation in us doing this, we'll move that. And over time, like Amazon, for example, are very strongly moving in the direction of building out support for things like Oracle. They're saying we want to be able to support all these IT workloads. Google are kind of saying we've got all these great systems for developers to build what's next. And we're building out a lot of the things that they're building at a different kind of rate, and they're building some of these higher level services a little bit later as well. So I think there'll be a convergence eventually, but I don't think there's a clear answer to that.
Yeah, more specifically around the video, content streaming, and that sort of thing, where it's not traditional voice, but it's really the mobile data and video.
Yeah.
It's changing the way they architect their systems, and so they've got to make some important choices.
Yes, so the question was how telcos architect their systems for video. The reason we have the big network that we have at Google is because we run the world's largest cat video provider. And we need to be able to deliver these things to people at as low cost as possible. Again, the monetization is small compared to the cost of moving video around. So we have a very large edge network. Popular videos are able to be cached near people. There is interoperability there. As it changes, like previously you might have had to peer with someone very centrally, but now compared to other companies, we actually push our content out as close to people as possible. So as a cloud provider, we're starting to make it possible that you can run regional storage in a lot of those locations and then deliver things. And there are a lot of vendors who are looking at ways they can cut costs by using a network like this. Any more questions? Well, that's right on time. Thank you all very much.